Good day. In this video, we're going to go through a word problem as seen on the screen about fractions so that we can understand how to use division of fractions in real life or word problems that try to model real life. So let's begin. Let's read the problem. A carpenter wants to cut a wooden plank 8/10 meters long into smaller pieces of length 1/5 meters each. What is the greatest number of such smaller pieces of wood he will get? It's very important that we highlight the different parts of the problem and try to model or sketch what the problem actually looks like. So as you can see here, we have a wooden plank. It's this long, 8/10 meters, and you want to cut it into smaller pieces of length 1/5 meters each. And we want to know the greatest number of such smaller pieces of wood that he will get. So let's try to split this bar into 10 parts to show 8/10. 1, 3, 4, 5, 6, 7, 8, 9, 10. There you go. That way, we can now try to show 8/10. 1, 2, 3, 4, 5, 6, 7, 8. So now we've marked this as 8/10, but we've also been able to divide the fraction into 1/5 meters each, and that's 1/5, another fifth, another fifth, another fifth, and the unshaded is another fifth. The good thing about this is you can clearly see how the division happened. This is 1/5, this is 1/5, this is 1/5, and up to here where the measure of the wooden plank is, it's also 1/5. So if you cut an 8/10 meter long wooden plank into smaller pieces of length 1/5 meter each, you should get 4. So 4 pieces. And if you look at the model that we have, this is basically division of a proper fraction and a proper fraction. That's pretty much 8 out of 10 divided by 1/5. You should get 4. Method 1, first approach. Now, we can try to use the reciprocal to confirm our answer. Method 2, we can say that the reciprocal of 1/5 is 5/1. So 8/10, and instead of dividing, we multiply it by the reciprocal, 5/1. You will get 40/10 or 4. So we can say that we will have 4 smaller pieces of wood. Now let's move to a slight variation of this problem so that we can look into the use of division in a different context or situation. Now, if you notice, the problem is phrased the same way, with the only difference being the fractional values. It's now a 7/10 meter long wooden plank, and you want to cut it this time into smaller pieces of 1/9 meter each. Now, if we draw our plank, and we draw 7/10 this time, one thing you'll notice is that it's now a lot harder to try to match and use the 1/9 to divide the plank altogether. So this is 5. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So if you remember, in the previous example, what we did was get the fraction 5 and 7. And this is our 7/10. And we wanted to divide this portion here by 1/9 meters. And if you notice, it's not easy to do that anymore. But we may be able to make a sense of it by trying to sketch what 1/9 actually looks like. So this is not accurate, but one thing for sure, we can draw and try to do our best to make a figure that's 9 parts. 3, 4, 5, 6, 7, 8, 9. So since we're cutting it by ninths, let's try to make matches this time. Here, so this is, I'm trying to draw dotted lines or lines to somehow match, make a correspondence here. There you go. So 1/9 covers up to this part. So that's 1, 2, 3, 4, 5, and then 6 up to here, and change. So the beauty of just making a sketch is that it helps you estimate or make sense of what could be the answer. So there are situations or fractional values wherein it's very hard to actually cut it. In fact, since the denominator here is 10 and 9, the closest common multiple that we have, or the least common multiple of 10 and 9, is actually 90. So you will have to rewrite all of this into 90 parts to be able to divide it carefully. So 7/10 will actually become, this is 90, this is 63, right? And then 1/9, if you make the denominator 90, that's 10 over 90. So if you think carefully, writing the equivalent fractions can help support your thinking of the problem. And this will give you an idea that you're actually dividing. So if we divide, we can use the reciprocal, because we're just literally counting how many 10/9 are there in 63 over 90. So let's try that. 7/10 divided by 1/9. Let's look for the reciprocal of 1/9. That is actually 9 over 1. So we can write that as 7 over 10 times 9 over 1. And this is 63 over 10. And if you notice, if you write this in mixed number, you will get how many 10s in 63? There are 6 10s in 63, and you have a remainder of 3 over 10. Meaning, in this problem, with a slight change in the values, the answer is not exact. But that doesn't matter necessarily, because it says here, what is the greatest number of such smaller pieces of wood will he get? And in this case, if we're going to be strict with how many 1/9 meter smaller pieces of wood, we will only actually have 6 smaller pieces of wood, because the fractional part does not really amount to 1/9 meter. So 6 smaller pieces. Okay? So for this video on applying division in word problems, division of fractions in word problems, we can see that modeling and getting an exact answer can only go so far. But that doesn't mean you can't make a sketch of a model to help you think about it. So we'll be talking about more examples in the next video. Have a great day.